Hello students, welcome to my channel. In this video we are going to discuss properties of bases and their applications. Right, to start with some basic properties of bases actually.
Chemical behavior?
Yes.
Bases react with some metals like zinc and liberate hydrogen. For example, when sodium hydroxide reacts with a metal like zinc, it liberates hydrogen gas along with the formation of sodium zincate.
See, this is sodium zincate. Why? This is the base, this is the metal. So what is the reaction? Base plus metal, right? They give what they give? Metal oxide. क्या दिया इन्होंने? Metal oxide plus hydrogen. So when bases react with metal, they give metal oxide and hydrogen gas. This is the same reaction as we have discussed in acids. When acids react with metal.
I don't see any gas. How can you say it's hydrogen gas?
And just repeating the question.
The liberated gas can be tested with a burning splinter, which is put off with a pop sound indicating the presence of hydrogen gas.
What's next?
Bases react with non-metallic oxides to form salt and water. This is very similar to a neutralization reaction between an acid and a base.
As we know,
From
neutralization
this,
means
it can be concluded that non-metallic oxides are acidic in nature. Consider an example. When carbon dioxide gas is allowed to pass through calcium hydroxide, it results in the formation of calcium carbonate and water. Now, can you tell some of the uses of bases?
Yes. Bases neutralize the acidity caused in my stomach.
Not all bases, only mild bases neutralize the acidity.
always
Apart
remember.
from that, bases have a variety of uses in daily life. Let's look at some of them. Bases like sodium hydroxide are used in the manufacture of soaps, paper, and synthetic fibers like rayon. A base like calcium hydroxide is used to manufacture bleaching powder. Bleaching powder is used as a disinfectant. Magnesium hydroxide is used as an antacid to neutralize the acid produced in the stomach. This is similar to the one you have taken to obtain relief from your acidity problem. Bases are useful to plants too. A base like ammonium hydroxide is used in the preparation of fertilizers.
And what is ammonium hydroxide? It can be written as NH4OH, ammonium hydroxide. This is the ammonium and this is hydroxide. This is plus, this is minus, right? Now you can write any molecule, any formula in this state of
Like
plus minus.
ammonium phosphate and ammonium sulfate.
Since the sea is considered to be the largest water body on the earth,
Yes.
why is the water so salty that we can't drink it?
The seawater is so salty because it contains large amounts of dissolved salts.
Do we get the salt which we use in our food from the sea?
Yes, of course. Along with common salt, you can get other salts from the sea. Some salts are prepared in laboratories. This lesson is about the occurrence and uses of different salts. At the end of this lesson, you will be able to define salt, list the uses of sodium chloride, explain water of crystallization using an experiment, and list the uses of plaster of Paris.
Plaster of Paris, POP.
The product of an acid reacting with a base is salt and water.
And this is neutralization. What is neutralization? Any salt is formed any water means any combined state means salt plus water. When acid reacts with base, this is the acid, right, react with base. And how is this acid? Because it has H plus ion. How is it base? Because it has OH minus ion, right, OH minus, and it becomes salt. And this metal, this water. For example, I am taking HCl plus NaOH. They become NaCl plus water, H2O. Na is this, that means this was base. This was sodium, B. B and A means Cl means A. So that can be written as a general formula. Ha plus BOH gives Ba plus HOH means water.
From this, we define salt as a compound formed by the reaction between an acid and a base. This reaction is called a neutralization reaction. For example, when an acid like hydrochloric acid reacts with sodium hydroxide, which is a base, sodium chloride, which is a salt, is formed.
Oh, salt which we use in our food?
Yes. Some salts like sodium chloride are edible, and other salts like magnesium chloride, potassium nitrate, zinc carbonate, and copper sulfate are useful to us.
Do these salts have any unique properties?
Salts are mostly solids and are ionic compounds. Every salt has a positively charged cation and negatively charged anion. For example, sodium chloride is made of sodium ions and chloride ions. Do you know how these salts get their name?
No idea.
Salts usually get their name from the acid which takes part in the reaction. Salts formed from any hydroxide and hydrochloric acid are chlorides. For example, potassium hydroxide reacts with hydrochloric acid to form a salt called potassium chloride.
Is it clear?
Similarly, salts formed from any hydroxide and sulfuric acid are called sulfates.
Clear?
For example,
From the name of acids, the salt is taken. From the name of acids. Suppose I am taking the example of hydrochloric acid, hydrogen chloride, plus NaOH, it gives, see, plus, minus, plus, minus. Sodium is what? Metal. It is having positive charge. OH is hydroxyl having negative charge. H plus है, Cl minus, and this gives NaCl प्लस माइनस इंटरेक्शन होगा, इंटरचेंज हो जाएंगे, प्लस जाएगा माइनस के साथ में और ये प्लस जाएगा इस माइनस के साथ में, तो क्या बन गया Na plus Cl minus, now sodium chloride. तो वॉट एवर इज द एसिड, द सॉल्ट इज गिवन द नेम according to the acids used, right? According to the acids used.
magnesium hydroxide reacts with sulfuric acid to form magnesium sulfate. Accordingly, salts
Note it
formed
down.
from any hydroxide and nitric acid are known as nitrates.
नाइट्रेट्स बना देंगे.
Ammonium hydroxide reacts with nitric acid to form the salt ammonium nitrate. Likewise,
Write down all the
salts
examples.
formed from any hydroxide and carbonic acid are carbonates.
Example,
Sodium hydroxide reacts with carbonic acid to form the salt sodium carbonate.
you can write down the reaction. Hydroxide, when reacts with any carbonic acid, this gives carbonate, right? So whatever the acid taking, the name of salt will be according to the acid. Whether it is carbonic, then carbonates. It was sulfuric, salt became sulfate. Whether it was the chlorides, hydrogen chloride, HCl, hydrochloric, the salt became chlorides, right? So example taken, sodium hydroxide, and this is the carbonic acid, H2CO3, H2 plus CO3 minus. H2CO3, how is this H2CO3 is taken as plus minus? Just look at this example. Carbonate having 2 minus charge. Always remember carbonate, this is CO3, carbonate having 2 minus charges, right? 2 minus charges has to be balanced with 2 plus charge. That is why 2H plus ion, these combine to form this hydrogen carbonate, or you can say carbonic acid, right? These 2 minus are being balanced with these 2 plus. That is why the formula is H2CO3. Okay. Now, so this become sodium carbonate. According to the acid, whatever the acid, the salt will be according to the acid's name. So sodium carbonate and water. So this is the neutralization reaction, salt plus water, salt plus water. Okay. Sodium hydroxide means sodium hydroxide, the base, and this is the acid, again neutralized, become salt plus water.